welcome to this video. My name is Wycliffe, and in this session, I want to share with you how you can create a simple suitability map or suitability analysis. For example, if you want to grow tea, I know this is a tea growing region, but you are concerned about the altitude because that's one of the factors that affect where tea can be grown. So you want only to pick specific height or altitude. And you are also concerned about slope because if you plant your tea on a very steep slope, then managing the farm can be very difficult. As well as you are concerned about aspect because that is the sun facing slope. So those three topographic attributes. How can you then determine a combination of these three attributes of topography? Because there are so many other factors that affect where you plant tea. For example, rainfall, other infrastructure in the locality, business or nearness to the factory, tea processing factory or road network, infrastructure, labor. But for now, we are only concerned about three topographic attributes. How do we combine them? And with this knowledge, you can apply it anywhere where you want to combine several variables to arrive at regions that are satisfying all the three conditions. Okay, so let's dive in. Okay, once we are in R, what we start with is to load the library, which is RGE. And then because we will be drawing a region of interest, we also load map edit. Okay, then we will start by initializing our Google Earth engine so that we can run it within R. And then we draw our region of interest. For the region of interest, we will use draw features from map edit. And then we will mutate a name for it, like creating a name in the simple features. And we will call this name Nandi. So I will go and work or create our suitability map in Nandi. Remember, this is just a suitability map for in terms of topography. It has nothing to do with other variables that can determine where you grow tea. So then we select only the name variable, and then we pass it as an Earth Engine object, okay? So we use these draw features to pick our region of interest. For example, we can select the background color, the background base map, where we can see clearly where the tea fields are. So we want to identify regions within this area which are suitable in terms of a number of parameters, especially topographic parameters. So after getting our region of interest, we can center our map to the region of interest. So we center object, and then Earth Engine object is our region of interest, and then zoom level, we can pick maybe 12, okay? So our map will be centered around our region of interest, which we have prepared here. The next thing is to get the slope map or digital elevation model data. So I can call it elev, and then we say this elev is an image from Earth Engine. So it's Earth Engine image, and then we go to the data set because this data looks at the whole catalog. So SRTM, the first one, which is 30-meter resolution, okay? Then we might be interested actually in clipping it to the region of interest so that we are only working with a small area, right? Because it covers the whole world, okay? Then if we want to get slope at the data from this, we can just use EE terrain slope function, and then we pass the elev, which is already clipped to our region of interest. On the other hand, if we want aspect, then we just say EE terrain, and then from the terrain, we look for aspect function, and then again, we provide elev. Okay, so we have all the three variables that we want to look at their suitability. For example, we know that T does well at an altitude of around above 1500 meters. So if you are in a region that is above 1500 meters above the sea level, then T is likely to do well there. In terms of topography, we are not considering rainfall and the rest here, okay? So let us consider a mask for elevation, that is areas that are suitable for T in terms of elevation. So we are looking for areas that are greater than or equal to, right? So this is how we filter the image to pick only regions that are greater than or equal to, let's say 2000, right? So that's super high altitude. And even tea might not be doing well because it's maybe too cold for tea and the leaves will not, or the shoots will not grow at a faster rate that a farmer may need. But for this example, we don't mind, okay? Then for slope, we don't want to go to grow our tea in slopes that are above 30 degrees. This is measured in degrees. So 90 degrees would be like vertical wall, okay? And then in terms of aspect, which is the sun facing direction of the land, we can say we only need our regions that in terms of aspect are less than or equal to 90. That is areas, or we can say 180, because the north, from north, when we go east, that is 90 degree. When we go south, that is 180 degrees. So we want the sun facing angle. So we can say less than or equal to 180 degrees, okay? So we can run all this. And then now we have the masks that we need to combine. How do we combine these masks to get a suitable area? So our suitable mask will be a mask for elevation, a mask for elevation. And then what we do to this mask for elevation, we combine it in terms of using a function called AND. So where that is true, and also mask for slope, that is slope is less than 30 degrees, and the mask for aspect, that is aspect is also less than 180 degrees. All right, so that is the suitable areas for our tea cultivation in terms of topography, okay? So this would be the suitable mask, which is a binary thing. So if we want to mask and get a mask layer, we can update any of our variables up here. So we can say suitable area, because the first one is the mask, and then we can say suitable area is equal to, we can take elevation, and then we update it, that mask by suitable mask, right? Okay, so we've centered our object, then we can just do the visualization. So we can add layer to see which areas are suitable for tea growing. And then we start with suitable area. And then after that suitable area, we can give it a name. We don't have to give it any color. So we can give it a name like suitable areas topographically. That is in terms of slope, in terms of slope, in terms of altitude, and in terms of aspect. So these are the areas that within our region of interest are facing at least from the north, which is 90 degrees, which is 0 degrees, they are facing 90, which is east, and maximum of 180, which is south. So they are facing this direction from which the sun rises, and they can receive maximum sunlight in the morning. I mean, in the afternoon, normally in this region is a bit cloudy or rainy. So if you are targeting western side, then your plants may not receive maximum sunlight to photosynthesize and get more shoots and get more money from the factory, okay, when you deliver your product. We can add the mask. For example, we can add the mask layer, or just the boundary, because the mask layer is a binary, which is basically the same as this. So we can add our region of interest, but because this one we can name as ROI, region of interest. If we add our region of interest, it's gray, so we need to style it. So we can use $sign and then we style it. And in styling it, we only provide color and fill color. So we can give it a color of red, and then we say fill color is transparent. So transparent color is normally given by 6 Fs and then 2 zeros, okay? So, and then we can give it line width, which is width of maybe 4, okay? So that will remove the the fill which was here, and we can now have the region. We might provide a palette of green that will make it the suitable area. We can provide vis params, which is a list. And in the list, we only provide a palette, which is maybe green, okay? And then we provide name, okay? So that will make the suitable areas green. So if somebody wants to ask you, I want to plant tea in this region, and my interest is on areas that are above 2,000 meters above sea level, and they should be facing the sun in the morning, like at least a maximum of 180 degrees in terms of the direction the slope is facing. And then the steepness of the slope should be less than 30 degrees, because beyond that, erosion will finish my farm, will destroy the soil, okay? So you can simply use this and to combine the masks. First of all, you give thresholds on the layers. Of course, first of all, you create the layers, and terrain slope, terrain aspect help us to get that. Then you give the threshold. These ones should be well informed. These ones are just arbitrary for training now, but you should really get to the literature and get the exact values that are suitable for this region, okay? Of course, tea can grow even in 15, 1200. Some tea are grown almost near the sea level. So depending on your region, you can change these values. The main thing is to know how, and then you do them, and also to answer the questions of why are we doing this, not just how do we do it, to hit the keyboard and get some output without knowing why do we need this. Okay, so this can help in planning, the identifying areas that are suitable. It can also help you in identifying areas or people who are actually growing tea in maybe steep slopes. So are there some farms? Yeah, okay, like some tea farms appear to be in areas that are not meeting our threshold here. These are not official thresholds. So if you get the official thresholds, then you can go to the farmers and ask them, why are you planting tea in this kind of steep slope? You should avoid this because here there is high chances of erosion, yeah, because the slope is quite steep, okay? Thank you. If you like this kind of video, make sure to subscribe so that whenever I post a new one, you are getting them pretty fast. And also share with your friends who enjoy this kind of analysis. The link to this script I will leave in the description section of this video. Feel free to follow that link to my GitHub repository, grab the code, and reproduce it yourself for your own kind of analysis. You can add more variables here, or you can remove these and replace them completely with your own variables of interest, and enjoy coding. Bye-bye.